Good morning, you guys. We are going to look at multiplying polynomials today. So you can do an extension of your notes from Monday if you want to, or you can start these notes on a new page. Doesn't matter to me. You will have to take a picture of the notes from today and upload them so that I can give you credit for completing today's assignment. But whatever you want to do with that, it doesn't matter. But you do need to take notes on this. We only have 7 slides to get through today, so it's not going to be a very long lesson. I kind of find it enjoyable, which is probably the nerd in me, and that's okay. But I don't think you'll find this too terribly difficult. So let's get into what this means to multiply polynomials. So if you remember from our lesson on Monday, polynomials are algebraic expressions made up of terms. They usually have letters, variables, and numbers like coefficients or constants in them. And so a lot of times, and don't write this down, they look something like this: 2x squared plus 3x minus 4. That would be an example of a polynomial. Specifically, that's a trinomial, because if you remember, we talked about things with 3 terms were trinomials. And it's a second degree trinomial because the largest power that any of our terms have is 2. So we learned all about that stuff on Monday, and then you learned how to add and subtract them by combining like terms. Multiplying them is a little bit different. So we're going to look at what we have to do to be able to do that. So to multiply 2 polynomials, you have to multiply all the terms together. Now we're used to multiplying things like that using distributive property, where whatever we have out here gets multiplied, and you don't have to write this down either, by whatever we have on the inside. So if this was like 2x and this was x squared plus 3x minus 7, you would multiply 2x by everything here. But now we're dealing with multiplying 2 polynomials. So we're talking about something like we have x squared plus 2x being multiplied by everything here. So that means you have to multiply this term by everything and this term by everything. That becomes a lot of craziness if you try to do that with distributive property. So we're not going to use that as a strategy this time. There are some people who teach to do that, but for most people, I think that gets just too complicated to look at. So we're not going to use that. The most common method for multiplying polynomials is called the FOIL method. And this is the method I learned when I was in school. This is the method your folks probably learned when they were in school. And so I am going to show you this because you could potentially see this pop up on something. This is not the method we will use regularly, but the FOIL method tells us that if we're multiplying polynomials, specifically binomials is when FOIL works the best, then you can multiply things in this order: the first, then the outer, then the inner, and then the last. So what that means is if you had something like x plus 4 times x plus 2, then you would multiply the first 2 terms first. Hold on, y'all, Jasper's crying. Okay, so I'm back. If we had a problem like this and we were going to use this FOIL method, the FOIL method tells me that we would start by multiplying the first terms in both polynomials. So I would multiply the x from this one times the x from that one. That's the first part. And x times x would become x squared. And then I would multiply the outer terms. So that would be the 2 on the outside of each polynomial. So the x right here and the 2 right there. X times 2 would make positive 2x. Then I would multiply the inside terms, inner. That'd be the 4 here and the x here. 4 times x would make positive 4x. And then I would multiply the last terms in the polynomials. That would be the 4 here and the 2 here. 4 times 2 would make 8. Positive 8, so plus 8. From there, we would then have to see that the 2x and the 4x are like terms, and they would simplify to be 6x. And then the 8 and the x squared would come down. This would be the solution to that after it's been multiplied using the FOIL method. Now that method works, and it's not a bad method to learn, but it's really easy when you have a binomial times a binomial like what we have here, but we won't always have that situation. Sometimes we're going to have a binomial times a trinomial or a trinomial times a trinomial, and FOIL just doesn't really work in that situation. And so I'm going to show you another method that takes a little more work to set it up, but in the long run I think it's a little bit easier to work with. And so I call that method the box method. If you're not done writing these notes down or writing this example down, you can pause the video and get it and then continue on to the next one. So the box is what I'm going to call this next method. I don't know that it actually has a name. I don't know that other people actually use it, but it works for me, and so that's what I go with. So I prefer to use a box for multiplying polynomials. Here's how you do that. Number one, count all the terms in each polynomial. Then draw a box. With that many columns and rows. You're going to write the terms on the outsides of the box. Then you'll multiply the terms to fill the boxes. And then you will add any like terms together and write the terms in order from the highest to the lowest degree. And I'll show you what this means in just a second with an example. I'm going to move on ahead. If you're not done, which you're probably not, pause the video, finish it, and then unpause it and keep going. So here's an example of, or here's really two examples of a binomial times a binomial, and I'm going to show you how we can use a box for this instead of using the FOIL method. Again, FOIL method does work, but the box to me is just a little bit easier to think about. So when I think about this one, I've got, make this clear, 2 terms here, and I have 2 terms here. So I'm going to make a 2 by 2 box. So what I mean by that is I'm going to draw a box, and I'm going to break it up into 2 columns and 2 rows. And your box does not have to be nice and pretty like mine. It doesn't really matter. I just happen to have a rectangle tool, so I used it. So once I draw the box the size that I need it, I take the terms from one of the polynomials, and it doesn't matter which one you put where, but I'm going to take this x plus 1 and I'm going to write the terms above the boxes going this way. So an x and a positive 1. Then I'm going to go down the side over here and I'm going to write the second one, the x and the positive 2. This begins to look like a Punnett square from when you did genetics in science last year. So then to fill the boxes, which is what we're ultimately trying to do, we're going to multiply whatever is in each column by whatever is in each row. So for this square, I'm going to multiply the x by the x. X times x becomes x squared. For this box, I'm going to multiply the 1 times the x. 1 times x is just 1x. For this box, I do the x from up here times the 2 from this way. X times 2 is 2x. And for this one, I do the 1 times the 2. 1 times 2 makes 2. So that's the multiplying part. But now I still have to put my answer together because this doesn't really give an answer. It just multiplies it out for you. So when you look at this, typically, not always, but I don't know, probably 90% of the time, you're going to end up with like terms in the box. And the like terms are almost always diagonal from each other. So if you remember, to be alike, they have to have the same variable and the same exponent. So this is the only x squared term. But there's an x here and an x here that would be considered alike. So I can combine those two together when I go to write my answer. 2 is a constant, and it's the only constant, so I don't have anything to combine it with. So when I go to write my answer out, I'm going to start with the largest exponent, and write that term down first. So I write down the x squared. Then I'm going to combine these two. 2x plus 1x makes positive 3x. And then I have a positive 2. This is the multiplied form of that. We use the box to get there. All right, let me show you another one. So here we have a two terms, 1, 2, and another 2 terms, 1, 2. So I'm going to make another 2 by 2 box, just like what I made on the last one. So 2 columns, 2 rows. Again, it doesn't have to be perfect. Mine is not perfect, and I drew it with a... Okay, so then I'm going to label on the outside x plus 2. And then down the side, I'm going to do x minus 2. Again, if you put your x plus 2 over here and your x minus 2 up here, it doesn't matter. You should get the same answer. And then I'm going to multiply. X times x is x squared. 2 times x is 2x. X times negative 2 is negative 2x. And 2 times negative 2 is negative 4. So again, I'm multiplying that by getting what's in the row and what's in the column and multiplying them together. So the x times the x, the 2 times the x times the negative 2, the 2 times the negative 2. So then I write my answer out. So I have an x squared. I only have one of those. Now I have a positive 2x and a negative 2x. Those will combine to give me 0x. I don't have to write 0x because 0x is just 0. It goes away. So that cancels itself out. We don't write that down. And then there's only 1 minus 4. So x squared minus 4 is the multiplied form of that because the x is in the middle canceled. All right, pause the video. See if you can do set up and solve these two. So draw yourself a box, label it, multiply it, write your answers down, and then unpause it and see if you were correct. So for this one, we should have done another 2 by 2 box. If you didn't take the time to try this yourself, please stop the video and try this. It takes practice to get good at it, and watching me do it over and over is not necessarily the easiest or the best way to go about that. All right, so we'll make a 2 by 2 box. X minus 5, 8x minus 2. And then you multiply it. 8 times 3 is 24. X times x was x squared. 8 times negative 5 is negative 40. Still an x, so x. 3 times negative 2 is negative 6x. Negative 5 times negative 2 is positive 10. So from there, you should have recognized that the negative 40x and the negative 6x would be able to go together. They're alike. And so you would have written down 24x squared minus 46x, because negative 40 and negative 6 make negative 46, plus 10, because that's a positive 10. And then the next one, same deal, a 2 by 2, because there's 2 terms in the first and 2 terms in the second. And you would have done x plus 5 and x minus 3. X times x is x squared. 5 times x is 5x. X times negative 3 is negative 3x. 5 times negative 3 was negative 15. Again, the 5x and the 3x go together. So we end up with x squared. 5 plus negative 3 is positive 2x and negative 15. So that's how we use a box to do binomials times binomials. Let's look at when the box gets a little more complicated. Here we have some binomials and trinomials, or trinomials and trinomials multiplied by one another. And we can still use a box for that. We just have to have a different size box. So if you look at this one, write this one down. I need to give y'all time to do that. When we look at this one has 3 terms and this one has 2. So I'm going to have a 3 by 2 box. So it doesn't matter which way you go with that. You can go 3 this way and 2 down, or you can go 3 long and 2 across. Doesn't make any difference. All right, something like that. Doesn't have to be perfect. Okay. So if I go 3 across the top, I have to make sure I write my one with 3 terms across the top. So I'm going to write x squared, negative 19x, and 9. Positive. And then down the side, I'm going to write x squared and 5. Positive 5. So now that I have that set up, I'm going to do the exact same thing I did on the others. I'm just going to multiply. X squared times x squared becomes x to the 4th. Remember, you add those exponents. Negative 19x times x squared becomes negative 19x to the 3rd, because there's one x here, and 1 and 2 make 3. 9 times x squared will just be 9x squared. And then we do the same thing with the second row. X squared times 5 is 5x squared. Negative 19 times 5 is negative 95. This still has an x, so still put an x here. And then positive 9 times positive 5 is positive 45. Now this is going to be one that has the exception to the rule with the diagonals being able to combine. Because if you notice, we have an x to the 4th, we have an x to the 3rd, we have an x squared here and here. We have a plain x, and then we have a number with no variable at all. So from all of this, the ones that will combine are this one and this one, because they're both x squared terms. Nothing else matches, so nothing else can go together. So when I write my answer, x to the 4th goes first because it's the highest degree. Negative 19, x to the 3rd is next. Then my x squared term, so I'll add 9 and 5. They're both positive, so I'll get positive 14x squared. Then negative 95x, then positive 45. It's a long, drawn-out answer. It's not hard to get, though, when you make it with a box. Now let's do the same thing with this one. So this one, we have 3 terms in the first one, 3 terms in the second one. So I got to have a 3 by 3 box. So draw your box. Doesn't have to be perfect. 3 by 3. Alright, so I got my 3 by 3 box drawn. Lock it in so it doesn't move anywhere. Once you get your box drawn, you can label it. It doesn't matter which one you put across the top and which one you put down the side. You'll get the same answer. I'm going to put the first one across the top just because that's my habit. X squared positive 5x positive 1. Put 3x squared negative 10x and positive 15 down the side. Okay, then I'm going to multiply to fill in the boxes. So I'm going to do 3x squared times x squared. So the 3, x squared times x squared becomes x to the 4th. 2 plus 2 is 4. 5x times 3x squared, well 5 times 3 is 15. X times x squared is x to the 3rd. Remember, an x by itself is a 1, or x to the 1st. And then 1 times 3x squared will just be 3x squared. And I move to the second row and I do the same thing. X squared times negative 10. It's going to give me negative 10x to the 3rd, because x squared times x is x to the 3rd. Then I'll do negative 10x times 5x, which gives me negative 50. X times x is x squared. Then negative 10x times 1 is just going to be negative 10x. Then the last row, I'll do the 15 times each thing in the columns. So x squared times 15 will be 15x squared. 5x times 15 will be 75x. 1 times 15 will be just plain old 15. Now I need to look for things that are alike in the box. So there's only one term with x to the 4th. So 3x to the 4th will be the only one like that. There are 2 x to the 3rds though. There's 15x to the 3rd and negative 10x to the 3rd. So when I write down my answer, I've got to combine those two together. 15 plus negative 10 is positive 5x to the 3rd. Remember, I'm adding at this point to combine the like terms. Then I move on to my x squared. I have 3 of those that are going to have to go together. 3x squared, negative 50x squared, and 15x squared. So negative 50 plus 15 is negative 35, plus 3 is negative 32. You could add that in your calculator if you're not friends with integers, not a big deal. So negative 32x squared. Then I have 2 that are just plain x's. So I have to put together my 10x, negative 10x, and my 75x. So 75 plus negative 10 is positive 65x. And then the positive 15 is left over. And that would be your final answer to that. So the answers feel really complicated, but they're really not that hard to come up with if you use the box method to get all your numbers. All right. I'd like you guys to try to set up these two. So pause the video, see if you can work these the same way we just worked the two on the last one. And then unpause it and see if you work correct. Please legitimately pause the video and try them. So I made a 2x3 box for this one. And then for this other one, I'm making a 3x3. It has 3 terms. Okay, so for that one, I made a 3x3 box. Like that. So to work this one, when you made your 2x3 box, you put your 3x and your 2, positive 2. And you put your 8x squared, positive 6x, positive 5. And then you multiplied. 3 times 8 was 24. X times x squared is x to the third. 8 times 2. Shh, you're watching me. 16x squared. 3x times 6x is 18x squared, because x times x is x squared. 2 times 6x made 12x. No, don't push buttons. 3x times 5 would make 15x. 2 times 5 makes 10. And then your multiplying is done. You just have to combine what you can. So in this, you noticed your 16x squared and your 18x squared. Sorry, y'all. Weird race cars are going on. And then you would have also been able to combine your 12x and your 15x. Just a minute, Jackie. Mommy's almost done. So 24x to the third is the only x to the third term. 16 plus 18 would have made 34, positive 34x squared. 12 plus 15 would have made positive 27x. And then your positive 10. So you should have come up with that as your answer. All right, and then on the next one, what are you talking about? Oh, you're counting the numbers? Okay, so we put our first one across here and our second one down this way. If you put your first one down and your second one across, it's fine. You get the same answer. This is numbers because Mommy's teaching math. And then you multiplied. 5 times 2 and got 10. X squared times X squared is X to the 4th. Then 3x times 5x squared made 15x to the 3rd. I'm going to pause this real quick, y'all. I'm trying to put him back on something else. Okay, trying this again. So then to fill this box in, 4 times 5x squared would give you 20x squared. 2x squared times 6x, 2 times 6 is 12. X times x squared becomes x to the 3rd. Remember, an x by itself is like a 1. 1 plus 2 is 3. 3x times 6x, 6, 12, 18. X times x is x squared. 4 times 6x is 24x. And then everything times 2. 2x squared times 2 makes 4x squared. 3x times 2 makes 6x. 4 times 2 makes 8. And then you combined what you could. So hopefully you recognize that the x cubes could go together. The x squareds could go together. And the plain x's could go together. So your answer looked like 10x to the 4th, because it's the only one. 15 plus 12 made 27, positive 27, x to the 3rd. 20 plus 18 plus 4 makes 42, x squared. 24 plus 6 made 30x. And then the 8 that was left behind. Alright, you guys are going to do some practice with this to get even better at it. But that's how you use the box method to multiply polynomials. You'll have a beautiful day.